Thanks. Not going to log out. Oh. All right. Thank you. Well, I can present this one now. We're going to need your help here. Your machine really likes this presentation, so.
Actually, we're just going to stay here on the call for participation slide until more people participate.
Okay, we're going to ask the questions, so pay attention to this side. All right.
It's the monkey.
The open shirt. The open source routing forum, the idea for getting,
All right.
where is the incentive for this open source group to kind of create the support and deliver decent support? Because usually you have customers who are paying but they're doing well.
Well, so the incentive for them is that they do it for money. And this is how the market works, right?
The open source routing forum is going to be offering support as a commercial
Activity, right? So,
okay.
so OSRF it's a forum in ISC, the Internet Systems Consortium. And when we were looking around for how is it that we create a support organization to deal with things in the open software space. So personally, I don't like inventing things that don't need to be invented. And this model didn't need to be invented, right? There's an organization that's proven that it's perfectly capable of doing this sort of thing. If anyone has ever used Bind, the relationship between Bind and Bind Forum, where if you want support for Bind, IC is happy to provide that to you. You join the Bind Forum and you become a supported user of Bind. In a similar vein, right? If you want to become a supported user of this open source routing stack stuff, you can join the OSRF and you can become a supported user of this stuff. Bill will, I'm sure, be happy to field more specific questions like, how can I join? How much does it cost? What exactly do I get? And he'll give you his personal cell phone number for support.
Right. Thank you. I'm going to speak about what Verizon is looking at in software-defined networking. And if you have very technical questions, we have the folks that have been working on this for 3 or 4 years in the room, Ed Rathke, David Dyson, and Philip Sen. So I might deflect very technical questions. But I think the first thing we want to talk about, and this came out interestingly, I guess in the graphic here, but why does Verizon care? All right, and it's economics. All right, we've talked a lot about architecture in this meeting. We heard all the good reasons architecturally, in terms of freedom and innovation. Those are all very important. And making a business case within Verizon, the foremost reason right now that we're looking at this is for costs. All right, so what's shown on this rather complicated slide, the way it came out, is the red line on top there is basically the trend of revenue for any company. This could be Verizon, right? And it's ARPU, that's the average revenue per user across the top there. And the line that has sort of an interesting red area on the bottom and curves up, that's our current trend in cost structure. All right, so that's great, right? So you don't have to have an MBA to realize there's a problem here, right? All right. The timeline is in years, but not very many years. All right? It's not seconds, but it's not decades. All right? So we're still okay, but not for very long. And the concern is it's because the type of vertically integrated products that we buy today, all the way from transport up through routing and switching and everything else we do, isn't following the trend of our revenue. We need to find a major change, not an incremental improvement, but a major change to change our cost structure. So ideally, it would fall along the green line, right, which is down there, which would be a cost structure that, hopefully would at least match the trend line of the revenue. And that's the idea. And we believe that to do that, we have to do a very specific thing related to our infrastructure, and that's to move it off of purpose-built hardware that's sold to a small number of users, like the telcos or like the data center folks, and move on to commercially available off-the-shelf technology, basically merchant silicon. It's moving into that domain that will provide us a very huge savings, initially in CapEx, but I'll speak a little bit about operational savings as well. All right, that's the driver. Now, there's an advantage that we've talked about quite a bit in this conference, and so I won't belabor it, but clearly if we get into a software-defined network environment running on what I'll talk about as being data center hardware as opposed to telco hardware, it also allows for that innovation that we heard quite a bit about yesterday, so that we can bring new software, new capabilities, new services to market more quickly. All right, so there is an uplift in revenue potential as well. But that's sort of the risk, right? That may or may not occur depending on how open we can make this and what sort of development ecosystem we can form to come in and want to develop things on top of our network. But even without getting that uplift in innovation, we see a tremendous reason to go ahead and do this quickly because of cost savings. So what are some of the attributes that we think about in Verizon with SDN and success of it? We need a network operating system. We've heard quite a bit about that today. One of the attributes of it that we're running into problems with today is we need a service or application-oriented namespace. We're finding that we spend way too much time and buy way too much software and hardware today trying to make things work down at the IP level. Because everything attaches back to the IP address and the attachment point. And that's not really how we try to run our networks today. We're running on service-specific information, policy routing, service routing, that doesn't necessarily tie to an IP address at all. And yet, the way the network's built today, you have to somehow bind it back down. All right, so as we think about network operating systems, for SDN, we have to, in our view, we want to also be addressing the namespace problem. Right, resource virtualization is key to us. In the end, as a large network provider, we want to monetize whatever cost we're putting into the ground, even in software-defined networking. So it's multi-tenancy. We want our network to be used for Verizon's retail services, the services that we sell to our consumers, but just as importantly, we sell our services to other providers, whoever it may be. It could be folks sitting here, it could be any other of the Fortune 1000, it's whoever wants to use the network, that's who we sell to. So it really is a multi-tenancy sort of problem, not unlike you have in cloud computing today in the data center. So again, getting virtualization of the network so we have the elasticity and the aggregation, that's very important to make this successful in terms of being able to monetize it. Again, to do all of that, basically the first two items, you need the abstractions, and I think Dan mentioned it, we've heard the word abstractions more probably than any place else, so I won't go into that. But part of the abstractions and part of the advantage of all this is to decouple, right, the topology and the traffic and the interlayer dependencies. Right now, all of those things are very, very tightly tied in a global, IP MPLS network like Verizon runs. It's very hard to separate the underlying topology from what your IP forwarding looks like from what the services are you provide on that. We need to start cutting those layer dependencies. Again, that's another motivation for us to move to SDN. So those are the focus areas that come out of that, right? Virtualization for multiple services. So this is an area that, again, is one of the areas I think on the list for OpenFlow to look at, thinking about multiple instances and virtualization, but more broadly even than OpenFlow, just thinking about how do we support that. We need the standardization, of course, for aspects that make sense, and I think that was discussed actually much better than I can do it yesterday. I forget who the speaker was, but talking about, we certainly want to standardize what should be standardized and not standardize what we don't need to. But clearly, with the protocols going up, let's say north-south in this model, we'd like to get some standardization of those. Okay, it means to incrementally introduce the architecture, and I think, just found out, Stephen pointed out very nicely, there's ways to introduce things into a network carefully. You don't just change your network, and it's not going to happen here. You have to introduce it carefully. What we're facing, of course, is we have a lot of legacy. So for us, the ability to operate an SDN environment on top of, next to, or somehow interconnected to a legacy environment is critical. And that's another area of focus for Verizon in this. It's not just getting the right SDN architecture in place, but also how do we merge that back into and make it interact and useful to the legacy environment, because it would be a slow migration. All right, here's one big ugly picture I had to throw in, just to, as an engineer. This was obviously drawn by folks that drive stick shifts, as I said yesterday. But it gives an idea of where we envision the network is really going. Just to orient you, the left-hand side of this is the user of the network, the consumer. It could be an enterprise, it could be a home hanging off of our pond, it could be a 4G user. And then we have a bunch of offices. So as a telco, I think of those as central offices. But there's offices that are at the edge, there's offices that sort of aggregate up at a ladder level, if that's familiar to you, but a regional level. You can get out into the regional offices. And these things are pretty much connecting back then into either the internet, which is sort of the public network, or back, and here it says origin server, but it could be any sort of data center capability or services that Verizon is providing. The model that we're looking at is basically those centers become data centers. The CO transforms into a data center. It has that type of equipment. It has basically a few SKUs. It has servers, and it has storage. It has some very general and generic switching. And that's pretty much it. Now, underlying that, you need some kind of physical transport, and that is the dense WDM, packet optical transport, as Verizon calls it. And that's somewhat in place at this point in the metro networks. It's really building on top of it. But what this diagram tries to show with the colored dashes across it is really sort of different flows that all have to exist independently or in synchronization if there's some application that requires all of them. But trying to illustrate that we may still have very traditional flow of a user, on their laptop at home or their iPad at home getting to the web. That might not change. That's a red dotted line showing internet routing, and it's still going through a gateway router, so we have to peer out to the internet, and that's still a router. We haven't got one of these software LSRs yet. We're happy to talk to you about that. But so it goes out. Another aspect is just the forwarding, the blue lines there. And the forwarding can be done completely in software if we want to. Okay, depending on the nature of the traffic and the type, we can do complete software routing, or that could be software-enabled routing. In other words, more of an OpenFlow model where you have a switching element that's a simple Ethernet switch being controlled by OpenFlow. So if you can see it in green, it shows where there may be OpenFlow interfaces as part of this structure. And then, of course, the application layer as well. Because in the end, what we might be delivering to the customer is a real application. It's not just transport to something, but a customer's buying whatever it is. I mean, they're using some application, and the routing itself or the delivery of that service should be service aware. It shouldn't be hindered or handcuffed by the underlying technologies. So this is sort of the model of the vision, and again, it's not going to happen in a flash cut, but we're doing pieces of this already. So I wanted to talk a little bit about some OpenFlow and SDN use cases that Verizon sees sort of at the top of its list of I wouldn't say low-hanging fruit, it's all hard work, but things that we want to start with. Right, so there's some examples written here I'll speak about. But again, the guideline is that we're only going to do something in an external controller using OpenFlow if it's a real benefit. Because we're not an R&D environment. We're there and have to show some profitability and some return on this capital. So we are looking at cases where maybe we could do it with OpenFlow, but we are going to do them really where it adds advantage. So that could be either new features or sets that we couldn't do otherwise, or that we would have to do very inefficiently otherwise. All right, so those are the sort of cases we think about. So the first case I list here is traffic steering, where you're going to route basically the packets based on the service and application and not have anything to do really with the IP address. You might use the IP address as one piece of information in a longer list of information you're going to use to route. But the routing might include real-time information that might be part of the packet itself, so it might look deeper into the packet. It may also include information that you couple with that's static information, such as the subscriber profile, or maybe real-time information concerning the state of congestion of the network. So that bit of information, neither of those pieces of information are actually carried in the packet at all. So it's a matter of pulling lots of information together and doing software routing based on that, something that you really couldn't do in a router today. Okay, OpenFlow may complement that, and I'll give you a specific example. We're looking at using this for video, for delivering over-the-top video. right? Where based on the state of the network, the subscription of the subscriber, and what sort of service that the subscriber is getting, software is routing that packet, all right? What happens though is we're looking at every single packet, right? It works, but the problem is that in a long-lived flow, like a video flow, you're watching a Netflix movie, I'm really being inefficient in looking at every packet, because once I've looked at the first couple, I know it's a long-lived flow, and I do much better off to cut through routing. So adding OpenFlow into that mix would give me much more efficiency, because I use traffic steering or software-defined networking first to kind of look at the packets. If I determine it's a long-lived flow, pass that information to the OpenFlow controller, which will then set up a cut-through route through the network. So a combination of sort of pure software routing coupled with OpenFlow and that model could become a very efficient way to think about delivering service-aware, video-type services. Another example that's important to Verizon, particularly since the acquisition of Terramar, is hybrid cloud computing. Hybrid cloud computing, and most of you know, but the definition we're using there is pretty standard. It's where an enterprise customer has their data centers, their enterprise data centers, and they want to offload or share some compute capability with a public data center. So in this case, between a Terramar data center and an enterprise data center. And there's a lot of layers there, a lot of hindrances to making that work, so I won't go through all of them. Orchestration certainly is a big piece of that research going on today to figure out how you orchestrate between that. But one of the financial hindrances of doing that, one of the big hurdles we face, is that if an enterprise wants to do some offload to a public data center, they pretty much have to buy the bandwidth to get to that data center, and they're probably buying it on a 24/7 basis, right? So if they need 10 gig every once in a while, they bought a 10 gig link and they're paying for it on a recurring basis, and maybe only using it a couple hours a month. Very expensive, and that in fact is one of the reasons that hybrid cloud computing hasn't taken off as quickly as it probably should have. So one of the solutions here is to get to bandwidth on demand, to virtualize the network itself, tie that virtualization, that bandwidth on demand capability back in through the same virtualization layer and orchestration layer that's already being used to move the data sets, to move the VMs, but now that would also allow the network itself to come up with the appropriate bandwidth and back down as needed. Now again, that would allow a customer to pay for what they use, and because it's multi-tenancy, presumably we would have a lot of different enterprises coming in over that regional network. It becomes sort of a time sharing for us. Yeah, we're not maybe collecting as much money per customer, but it's still a very good business model because multiple, it's basically time sharing in a sense. Multiple users are using at different times, so it's sort of a win-win. It makes a lot of sense, and it's something that we think that we need to focus on with SDNs, particularly for the Terramar business units. All right. OpenFlow switching operated in hybrid modes, we heard quite a bit about already. Certainly mixing environments where we have native control already in an existing router, but we now want to add OpenFlow as well. Do we do that as ships in the night? Do we have some shared resources? And if so, how dynamically can we share those resources? And then lastly, OpenFlow switching, partitioning itself. So having multiple OpenFlow controllers that truly have slices, sort of in a Genie model, if you think about it that way. So that's sort of our list here of what's important to us that we're focusing on as use cases coming down through SDN. I have some pictures that, in the interest of time, I'm not going to run through all of them in detail. I put them in here because this will get distributed, I think, to all the attendees as PDF after the conference. So you can certainly contact me or the other folks here from Verizon to talk about it. And this just illustrates the idea of software-defined networking for traffic steering, as we call it. So traffic comes in, and we have all these applications sitting up over the switched network or the routed network. But it's not that every packet from every customer should traverse all of those applications, right? So what we can use with traffic switching, shown in the red, is based on a certain subscriber, the packets may only go to certain places. So this is something we're already implementing in the field today, and it works, but again, it has that inefficiency that every packet goes this way, even if it were, say, a long-lived flow. So the advantage that OpenFlow added to that would give us is once we've determined, hey, this is a flow maybe going from cache to the customer, instead of continuing to propagate it through the SDN and show up a lot of resources in terms of CPU cycles and interfaces in and out of the servers, we pass information over to an OpenFlow controller and do cut-through routing. Right, so that's an example. We haven't accomplished this yet. This is work that will be turning up in the lab at this point. Right, here's an example of the hybrid cloud. I mean, we talked about it. I think people understand it, but this is just a graphic to think about all the different aspects of SDN and OpenFlow that fit into that model. On the left-hand side, you have a couple of different private data centers that include the customers, the blue and the pink. You have some layer 2 or layer 3 network sitting between them that's connecting them back into the public data center. And a bunch of lines drawn here for different protocols and things. I won't go into all of that, but let's highlight the important ones. Potential use of OpenFlow is going and actually arranging the switches around that public network such that we can route things appropriately through the switches, okay, through the controllers. You see the green lines going down there where you're controlling the VPN assignments, basically deciding who's attached to what resources within the public data center. That's coming out of the controller and more fits into the model of SDN, all right? And then also shown in purple are the hybrid cloud APIs, and this is important, and I'm not going to spend time here, but it's another aspect that we need to think about. I think when you draw much more elegant pictures than these that was seen of the architecture for SDN, as you move up towards the top, you have the control layer over the virtualization layers and over the NOCs. If this isn't just used by a single entity like a Verizon or like a Google, and it really is something for others to use, other enterprises, we have to think about how all that gets exposed into the APIs. How are they coming in and controlling and requesting the resources, getting the resources? That's a big piece of this as well, is thinking about that aspect. I don't have to talk about Genie. I think there's people here certainly who are running some of the Genie program and can speak to it. But it is a good example of the idea of having virtual instances of OpenFlow so that you can actually create slices of network as they're termed. Again, very important in certain models. When we think about real-time communications as cloud services, you might think about a virtual instance of some sort of unified communication service or voice and multimedia service, and you're creating a slice that might be used by CenturyLink. Verizon might sell to them as a wholesale provider, and different ones who Sprint. Those have to be quite isolated, of course, and it's not sharing a network. It's really creating sort of a virtual network operator environment. And this is a place where having that virtualization and the ability to slice the network becomes very important. All right, so in summary, the driver from a cost perspective, and sort of the near-term interest, has Verizon's, excited about this, at the broad level of Verizon, is cost reduction, and because we're moving to commercial off-the-shelf infrastructure, right? It sounds great, but then you got to figure out what you're putting on it. That's what this conference is about, right? So you move towards COTS. That leads to an evolution of central offices look like and become data centers. So we get that great benefit that we have in data center technology today in terms of cost and scaling and service flexibility, right? And using cloud computing technologies, right? But we realize that some services then are going to be handled through a mix of what I would call pure SDN, really just pure software running on servers, and then invoking the OpenFlow controller for more efficient use of underlying switching and routing, basically cut-through switching. Hybrid cloud computing, it will also use sort of a mix of pure software-defined networking or software-defined routing, if you will, and OpenFlow. And that has to get linked in with the orchestration layers. That's a whole other area of quite a bit of activity today in the R&D community, but as well as in industry. All right, and we do believe that OpenFlow does require several enhancements to work in this environment, and I've sort of pointed them out without spelling out releases of OpenFlow, but areas of virtualization coming in later releases like 1.3, for instance, and areas of resiliency I didn't touch on, but of course making this work in a distributed environment but with the appropriate resiliency to keep slices up and running if one of the controllers goes down. So thinking along those lines that come in future work for the ONF. Right, that's it.